Ladies and gentlemen, we are starting our physics unit with our first TEK. This is 8.6a. We're going to talk about balanced and unbalanced forces. You have Cornell notes that look like this. So let's get going. Let's go ahead and answer that first question. Our essential question is, what is a force? Well, a force is simply put, it is a push or a pull. So your first blank is push, and then your next one is pull. Okay. And as you see on your Cornell notes, as you can see here on your Cornell notes, that a push, this is going in, and then the pull, of course, is pulling this direction. And you are going to have to be able to tell the difference between whether an object is pushing or pulling. Next, we need to pay attention that forces come in pairs. That's your next blank. It says remember on the side with 2 stars around it. Forces come in pairs, and they're going to have a magnitude and a direction. So magnitude is basically the amount. Okay, so forces are measured in newtons. You probably have used a spring scale before, and that measures the amount of force that an object is pulling against another object. So an example here is I have a magnitude of 5 newtons. Okay, that is, the newtons is the unit, and then direction will be north or up. So if I did this, I have a box. You'll see boxes is a common example. And I push in on this box 6 newtons. My magnitude is 6 newtons. And then my direction would be pushing to the left. Another example, let's look really quickly. Here on your notes, you have an example of 2 people that are pulling. This person, excuse me guys, this person here is pulling to the right 50 newtons. This person here is pulling to the left 40 newtons. So you have to ask yourself, who has the greater force? Well, this person right here does. And so what we're going to do is we're going to combine their forces. So you have to think about this logically. Are they both pulling in the same direction? Well, no. Since they're not, you need to subtract both of their magnitudes. So I'm going to subtract 50 minus 40, and I'm going to end up with a leftover or a net force of 10 newtons. Always got to have your unit. But where is the object gonna go? So just like in tug of war, whoever has the most force, it's gonna be pulled in that direction. So this is gonna go 10 newtons to the right because this person right here has applied more force. Alright, we are now on essential question number 2. It says balance forces on your left. Your balance forces do not cause a change in motion. That's your next 3 blanks. They do not cause a change in motion. Then they are equal in size, and they are opposite in direction. So what that means is this. If you have forces that are balanced, then the motion is not going to change. But that does not mean that the object is not in motion. It just means that if it is in motion, everything about the object is the same. So let me give you an example. Here is an example. Right now I have my little orange truck. Okay. Right now it's sitting on my desk. It is not in motion. So everything right now makes it balanced. So my truck right now is at rest. Now let's imagine that my truck is driving down the road at 4 meters per second. Okay, that's how fast it's going. Not very fast, but that's the constant speed that it has. If that's the case, and it doesn't run into anything, it doesn't hit anything, all the forces on it are balanced. As long as the speed is the same. If your speed is constant, then all the forces on it are still balanced. So here, let's look at the example here on your notes very quickly. Right here, here's an example. Okay, this one's pushing 4 newtons to the right. This one's pushing 4 newtons to the left. So you have an equal magnitude going in opposite directions. So your net force would be 0 newtons. This box is at rest. Okay, then you have this little horse. Sometimes they won't give you the amount of the magnitude. Sometimes they'll give you arrows. If the arrows are the same size and the same thickness, then that tells you that the forces are equal. So this horse, again, is not moving. They have a magnitude of 0 newtons. Everything acting on the horse is balanced. Now let's take care of our last essential question. Our unbalanced force, number 3. These always cause a change in motion. Change is your word. Now let's look underneath that. It says calculating net force. That's your next blank. Calculating net force. So basically, I've already shown you that. You take the two forces, and depending on if they're going in opposite directions or the same directions will determine whether or not you add or subtract. So it says on your notes, when forces are going in the same direction. So you're going to add when they're going in the same direction. If all the forces are going in the same direction, you're combining those forces, so you would add. Then you would subtract if they're going in different directions. So add for the same, subtract for different. And you always include the magnitude or the amount of force in newtons, as well as the direction. So last example, let's look down here at your notes. So here I have a box, and it's pushing in 12 newtons to my left, and this one is going 12 newtons to my right. So are both of these forces pushing in the same direction? If they're not, my notes say to subtract. If they're going in different directions, then it says to add when they're going in the same direction. So since they're going in different directions, I need to subtract. So 12 minus 12 is going to be 0 newtons. Oops. And then I look at this other one. Okay, I've got an arrow going this way. I've got an arrow going this way. They're going in opposite directions, so I need to again subtract. So 20 minus 3.7. Okay, I can't take 7 from 0. I gotta go borrow all the way from this 2. I know this is gonna become a 9, 10, 3, drop my decimal. 9 minus 3 is 6. So my net force is going to be 16.3 newtons. Okay, and which direction is it going to go? Well, it's going to go up and to the right. And ladies and gentlemen, that's pretty much it. I hope you saw the examples and wrote your notes. So make sure that if you're in class, you take care of business, or if you're doing this outside of class, that you're all caught up and following directions.